Hello everyone. In this video, we are going to study the Rutherford's nuclear model of atom and Bohr's stable orbit atomic model. Let me tell you, before these two models, we have already discussed the Dalton's atomic theory and J.J. Thomson's plum pudding model in the previous video. So we are going sequentially. The very first atomic theory was given by scientist Dalton and then Thomson. Then comes Rutherford's nuclear model and then the Bohr stable orbit. So yes, let's go for the first one. So we'll discuss here the Rutherford's nuclear model of atom, right? So what happened in the Rutherfords, what he did one experiment, okay? What the experiment of gold foil scattering experiment. He did in 1911. So as you can see here, there's one experimental setup as you can see here, I've shown by the pointer. So he has bombarded a very thin gold foil with a positively charged alpha particles. As you can see here, there's an alpha particle emitter which is emitting positively charged alpha particles, and upon which it is throwing on golden foil, a thin golden foil. The rectangular shape is a golden foil, and now the alpha particles will do something onto it. So to observe what the alpha particles are doing with the golden foil, a fluorescent screen is attached here. As you can see here, in a circular way, we have attached a fluorescent screen so that we can observe the effect of these alpha particles onto this screen. Okay, so there is one slit through which the alpha particles are moving, right? So this is the experimental setup and this is the experiment that he has performed. He has observed the path of all the alpha particles and what were the results. So I have shown here the four major important results that he has observed. The first one is the most alpha particles went straight to the foil. Okay. The thing is that here we are not giving exactly numbers. The most alpha particles went straight to the foil. Okay. Straight to the foil without, as if there is no any obstacle in the path. Okay. Second, a small number of alpha particles were deflected at a small angle, and even a smaller number of alpha particles were deflected at a large angle. So I hope you know that what is meant by deflection angle, and if you don't know, I have explained here in a small figure. So for example, if this is the incident ray without any obstacle, it's supposed to go from left to right. But if the obstacle is there where I have pointed, A ray A is deflected with a deflection angle x degree, and the ray B has deflected with a deflection y degree. So definitely B is having the higher deflection angle, A is having the lower deflection angle, right? A small deflection and a large deflection. That is the concept, right? So yeah. And the fourth one, a very small number of alpha particle bounced back in the opposite direction. Okay. Bounced back means some has gone through gold foil straightly, some has gone deflected with a small angle, some has deflected at a large angle, and some has bounced back in the opposite direction. So these were the results that he has found on this fluorescent screen. So based on these results, he has concluded something. So what he has concluded, we'll see. The conclusions were most of the atom is having the empty space. Why he is saying the most of the atom is having empty space? What is mean by empty? Empty means without any obstacle. Why is saying without any obstacle? Because in the result, what we got, the first result, most alpha particles went straight to the foil. If it is straight, that means there is no obstacle. If there is no obstacle, means the space is empty. It is that simple. Second, the first result was most of the alpha particles went straight, and the rest three was small deflection angle, large deflection angle, and straight opposite in the direction. So that means there is some obstacle, right? So what is that? A small, dense, positively charged region at the center of atom, which is called as nucleus. See here, this model we are studying, the name of this model is Rutherford's nuclear model. Okay. And why the name is nuclear? Because he has discovered, or he has given us the new terminology, that is in nucleus. And why he is defining nucleus like that? Why it is small? Because if it is large, the most alpha particles would not have gone straight to the foil, right? Here, most have gone. So that's why the nucleus must be small in size, right? Why we are saying here dense? What is the meaning of atomic mass? We'll explain in the next point. Positively charged region. Why we are saying this nucleus is positively charged? So in physics, this is a common simple terminology, or you can say positive and negative opposites will attract, but positive positive or negative negative will repel each other, right? So as they are deflecting means they are repelling, that means alpha particles are positively charged and still they are deflecting, means the obstacle through which they are deflecting, it must be positively charged, right? So yes, why he has declared nucleus like that, I hope you understood, right? Okay, so this experimental setup we have seen the results and we have seen the conclusions. So based on these observation, based on these conclusion, he has proposed a new model of atom. Okay, a new model of atom. Before that, I hope you remember the Thomson's plum pudding model. He has added a nucleus into that, and let's see what is that. Okay, so nuclear model we'll discuss. Okay, the first one is atom have a small, dense, positively charged nucleus at the center and atomic mass is concentrated. Now there's one terminology called atomic mass. It means overall mass or overall weight of atom. Okay. Now we know that in the atom there are two parts that he has proposed. One is nucleus and another's are electrons. Okay. I hope you remember in the Thomson's plum pudding model that we have written there electrons, those are in the atoms having the weight 1800 times less than the hydrogen weight, right? Hydrogen mass. So that means the weight of these electrons are negligible. Okay. If the weight of the electrons are negligible, means atomic mass you can say is concentrated at the center, right? I hope you're getting the first point. The mass is concentrated at the center. Second, negatively charged electrons revolving around the nucleus. Now he is saying, yes, there are electrons, there are negatively charged electrons, and those are revolving around the nucleus. Now we are again saying the same thing that has put by the Thomson, that this atom is electrically neutral. Electrons are having negative charge and nucleus is having positive charge. So positive charge and negative charge are equal and they balance each other, and that's why the atom is electrically neutral. In the third point, I want to clear you that we have called here the charge and not the weight. Mass is different and this charge is different, right? So yes, last one, the large empty space between the revolving electrons and nucleus. Yes, in the atom, we have a nucleus, we have some moving electrons, and in between, there is a large space. There is an empty space. And why there's empty space? This empty space through which this alpha particle has moved in the experiment. Okay, so there's a space he has mentioned in the atomic model. I hope you understood this Rutherford's nuclear atomic model. We'll go to the next slide. Here you can see here what is written. Classical physics theory, an electrically charged body in a circular orbit will lose its energy. Okay, there is very well accepted theory, or you can say a law, that the electrically charged body, if it is moving round and round, if it is moving in a circular orbit, definitely that charged body is going to lose its energy. Okay, so as per this theory is well accepted. The Rutherford model become unstable because in that the electrons are revolving around the nucleus. But the thing is that in actual atoms are stable, right? So to overcome these problems, Bohr's atomic model has come into the picture in 1913. And what is that? We'll see. So as you can see here, Bohr's atomic model. Okay, Bohr's stable orbit atomic model, you can say like that. So here, as you can see here, we'll first go to the diagram directly. It has a nucleus, positively charged nucleus, and it has electrons. Now, what Bohr's has added into this? Let's see. Electrons having the fixed orbits. What what was defined in the previous model? It was defined as the electrons. Rutherford's model, electrons are moving around the nucleus. What Bohr has suggested that yes, electrons are moving in the circular motion around the nucleus, but they move in a particular path. They move in a fixed orbit. Okay. So as you can see here in the figure, I have given the number 1, 2, 3, 4. They are also named as K, L, M, N, and these are called as shells. These are also called as orbit. These are called as shells or orbit, and that's why the Bohr's stable orbit atomic model name came into the picture, right? Because the electrons move in a particular orbit only. For example, this one is showing this path, the second orbit is showing this path. It means in between 1 and 2, there is, even though there is a space, electron cannot be there. Electron could be either on 1 or 2 or 3. Okay, so electrons can have only certain amount of energy which are determined by the orbits. Okay, the second thing, the first point they are saying about the orbit, second point they are saying about the energy. If the electron is having, if the one electron is there in the first orbit and the second electron is there on the second orbit, definitely they are having different energy levels. If two electrons there in the first orbit, it means these two electrons are having same energy level. Okay, understood? If the two electrons, many number of electrons is there on second and second orbit, that means the energy of all the electrons in the same orbit is going to be the same. So how they exchange the energy? So absorb energy, jump to a higher orbit, emit energy when they jump to a lower orbit. So if electron is there who wants to go from first orbit to second orbit or first shell to second shell, if they want to jump to higher orbit, when they want to jump to higher orbit, they have to absorb the energy. Okay. And if they want to jump to a lower orbit, means if the electron is there in a third shell and it want to go to second shell, it has to emit energy. And how much energy? The energy which is equals to the difference of these two energy level. Okay, difference of these two energy level. So yeah, that is the Bohr's atomic model, where he has given this orbital model, stable orbital model, right? So next, in this slide I have given you, I have shown you the quick journey of all the atomic theory that we have discussed till now. The very first discussed is the Dalton's atomic theory, where he has proposed the atom is the spherical and the mass is distributed uniformly, and there were no inside structure and it is indivisible. Second, Thomson's plum pudding model, he has discovered one thing, new one thing is the electrons, is negatively charged electrons, right? And they are random in nature. Only the thing is that negative and the spread positive charge that is shown in pink are equal, and hence the atom is neutral. In the Rutherford model, because of the gold foil experiment, what he has got is the nucleus name terminology. Like nucleus is there, positively charged, dense, and all the atomic mass is centered over here. Okay, so this is Rutherford's atomic model. There's nucleus and the electrons are revolving around it. And to overcome some shortcomings of this model, Bohr's stable orbit atomic model came into the picture, where he has defined nucleus, orbits, energy level, and their stability, right? So yes, and even Bohr's model you cannot say is the last one, but yes, Bohr's model you can say a major advance over this Rutherford model, because it had explained the stability of atom. Um, Even if it's not a perfect model, so many other atomic model has been discussed after that. There is one branch of science called quantum mechanics, wherein all the study about the atomic structure of atom has been done. and all well accepted fundamental principles of atomic structure were put forth, which will be discussed in the next video. Till then, thank you.